Welcome dear student to class 9 Science and Technology part 1. We are going to continue chapter 1 Laws of Motion. This is the second part of the chapter. In this part we are going to discuss effects of speed and direction on the velocity. Secondly, we will study uniform and non-uniform linear motion. Thereafter, we will discuss about acceleration. Then we will study different graphs of objects which are in uniform as well as non-uniform linear motion, like distance time graph, velocity time graph. So let us begin with the first point, effects of speed and direction on velocity. Here, let us consider Sachin is traveling on a motorbike. Explain what will happen in the different cases. 1. What will be the effect on velocity of motorcycle if its speed increases or decreases but the direction is constant? That is, direction remains unchanged. So here we can observe if the direction remains unchanged and object is moving with increasing speed, then velocity will also increase. While on decreasing speed, velocity also will decrease. Second condition, in case on turning on the road, will the velocity and speed be same? If Sachin changes the direction of motorcycle by keeping speed constant, what will be the effect on velocity? In this case, we observe velocity will change only in terms of direction, while its magnitude will remain same. Let's see the last case. If Sachin changes his speed as well as direction on the turn, what will be the effect on velocity of motorcycle? In this case, dear friends, velocity will change with both, with its direction as well as its magnitude. From this discussion, we came to know velocity depends on the two factors, its speed as well as direction. We can keep changing the speed while keeping direction same. Second, changing direction while keeping speed same. And changing the speed as well as direction.
Dear students, always remember the first scientist to measure speed as the distance per time was Galileo Galilei. The speed of sound in dry air is 343.2 meter per second, while the speed of light is about 3 into 10 to the power 8 meter per second. The speed of revolution of the earth around the sun is about 29,770 meter per second.
Let us now see uniform linear motion and non-uniform linear motion. Here we take a chart which is showing the motion of the three friends Amar, Akbar and Anthony. Let us observe all the readings and answer the following questions.
In this chart, in the first column, time in the clock is given. In the second column, distance covered by Amar in kilometer is given. In the third column, distance covered by Akbar in kilometer is given. And in the fourth column, distance covered by Anthony in kilometer is given. Time is taken in the interval of every half an hour. 5 o'clock, 5:30 o'clock, 6 o'clock, 6:30 o'clock, 7 o'clock and 7:30. Here we observe distance covered by Amar is 0 kilometers, 20 kilometers, 40 kilometers, 60 kilometers, 80 kilometers and 100 kilometers at the last. While that of distance covered by Akbar in kilometers is 0 kilometers, 18 kilometers, 36 kilometers, 42 kilometers, 70 kilometers, 95 kilometers. While that of distance covered by Anthony in kilometers is 0 kilometer, 14 kilometer, 28 kilometer, 42 kilometers, 56 kilometers and 70 kilometers. We observe here distance covered by Amar in unit interval of time is constantly changing. That is, per half an hour, Amar travels 20 kilometers each time. Similarly, distance covered by Anthony is also uniform. In every half an hour, he covered distance of 14 kilometers. While in case of Akbar, the distance covered is non-uniform in the uniform interval of time. Dear friends, use your brain power to answer these questions. Question 1. What is the time interval between the noting of distances made by Amar, Akbar and Anthony? Answer. It is the time interval of 30 minutes. Second, who has covered equal distances in equal time intervals? Answer. Amar and Anthony has covered equal distances in equal interval of time. Fourth question. Considering the distances covered by Amar, Akbar and Anthony in fixed time interval, what can you say about their speeds? We can see Amar and Anthony are traveling with the uniform speed. It means if an object covers equal distance in equal time interval, it is said to be moving with uniform speed. If an object covers unequal distances in equal time interval, it is said to be moving with non-uniform speed.
From this discussion, we come to conclusion that if an object covers equal interval of distance in equal time interval, it is said to be object is moving with the uniform speed. When an object is covering equal interval of distance in the equal unit interval of time, then object is said to be in the uniform motion. If an object covers unequal distance in the equal interval of time, it is said to be non-uniform motion. And when it is non-uniform motion, the speed of object is also a non-uniform. Dear friends, let us move now to the next point, that is acceleration. For this, let us observe a small activity.
Let us try this. Take a 1 meter long plastic tube and cut it lengthwise into two halves. Take one of the channel shaped piece, place one of its end on the ground and hold the other at some height from the ground as shown in the figure. Take a small ball and release it from the upper end of the channel. Now observe the velocity of the ball as it rolls down along the channel. Is its velocity same at all points? Observe how velocity changes as it moves from the top through the middle and to the bottom. You must have all played on the slide in park. You know that while sliding down, the velocity is less at the top. It increases in the middle and decreases, becomes zero towards the end. The rate of change of velocity is called acceleration.
By this activity, we learn a rate of change of velocity is called as acceleration. It can be calculated with the formula final velocity minus initial velocity upon time. That is, A is equal to V minus U upon T. SI unit of acceleration is meter per second square, while that of CGS unit is centimeter per second square. If the velocity changes by the equal interval of time, then it is called as uniformly accelerated motion. On the other hand, when velocity changes by unequally at regular interval of time, then the motion is said to be non-uniform accelerated motion. Dear students, acceleration can be positive, negative or zero. When velocity of an object increases, then acceleration is said to be positive acceleration. In this case, acceleration is in the direction of velocity. Secondly, when velocity of an object decreases with the time, then it is said to be negative acceleration. Here, the direction of velocity and acceleration is opposite. It is also called as deceleration. If velocity of moving object does not change, it remains constant. In this case, acceleration is said to be zero acceleration. Dear students, now let us study the distance time graph for uniform and non-uniform motion.
The following table shows the distances covered by a car in fixed time intervals. Draw a graph of distance against time, taking time along the x-axis and distance along the y-axis in figure. Time in seconds, 0. Distance in meters, 0. Time in seconds, 10. Distance in meters, 15. Time in seconds, 20. Distance in meters, 30. Time in seconds, 30. Distance in meters, 45. Time in seconds, 40. Distance in meters, 60. Time in seconds, 50. Distance in meters, 75. Time in seconds, 60. Distance in meters, 90. Time in seconds, 70. Distance in meters, 105. An object in uniform motion covers equal distances in equal time intervals. Thus, the graph between distance and time is a straight line. Use your brain power. In the distance time graph above, what does the slope of the straight line indicate? Distance time graph for non-uniform motion. The following table shows the distances covered by a bus in equal time intervals. Draw a graph of distance against time, taking the time along the x-axis and distance along the y-axis. Does the graph show a direct proportionality between distance and time? Time in seconds, 0. Distance in meters, 0. Time in seconds, 5. Distance in meters, 7. Time in seconds, 10. Distance in meters, 12. Time in seconds, 15. Distance in meters, 20. Time in seconds, 20. Distance in meters, 30. Time in seconds, 25. Distance in meters, 41. Time in seconds, 30. Distance in meters, 50. Time in seconds, 35. Distance in meters, 58. Here, the distance changes non-uniformly with time. Thus, the bus is having non-uniform motion. Use your brain power. What difference do you see in the distance time graphs for uniform and non-uniform motion?
Now let us study velocity time graph for both uniform and non-uniform motion.
A train is moving with a uniform velocity of 60 kilometers per hour for 5 hours. The velocity time graph for this uniform motion is shown in figure 1. With the help of the graph, how will you determine the distance covered by the train between 2 and 4 hours? 2. Is there a relation between the distance covered by the train between 2 and 4 hours and the area of a particular quadrangle in the graph? What is the acceleration of the train? The changes in the velocity of a car in specific time intervals are given in the following table. Time in seconds, 0. Velocity, meter per seconds, 0. Time in seconds, 5. Velocity in meter per seconds, 8. Time in seconds, 10. Velocity in meter per seconds, 16. Time in seconds, 15. Velocity in meter per seconds, 24. Time in seconds, 20. Velocity in meter per seconds, 32. Time in seconds, 25. Velocity in meter per seconds, 40. Time in seconds, 30. Velocity in meter per seconds, 48. Time in seconds, 35. Velocity in meter per seconds, 56. The velocity time graph in figure shows that 1. The velocity changes by equal amounts in equal time intervals. Thus, this is uniformly accelerated motion. How much does the velocity change every 5 minutes? 2. For all uniformly accelerated motions, the velocity time graph is a straight line. 3. For non-uniformly accelerated motions, the velocity time graph may have any shape depending on how the acceleration changes with time. From the graph, we can determine the distance covered by the car between the 10th and the 20th seconds, as we did in the case of the train in the previous example. The difference is that the velocity of the car is not constant, unlike that of the train, but is continuously changing because of uniform acceleration. In such a case, we have to use the average velocity of the car in the given time interval to determine the distance covered in that interval. From the graph, the average velocity of the car is equal to 32 plus 16 upon 2, which is equal to 24 meters per second. Multiplying this by the time interval, that is 10 seconds, gives us the distance covered by the car. Distance covered is equal to 24 meters per second multiplied by 10 seconds, which is equal to 240 meters. Check that, similar to the example of the train, the distance covered is given by the area of quadrangle ABCD. Area of square ABCD is equal to area of square AECD plus area of triangle ABE.
In the next period, we will meet with the next topic. Till then, keep revising the learned topics. Thank you very much.